All right, hello everyone, and thank you for joining today's webinar. My name is Nate Spurley, and I'm a sales engineer at RISA. For our limited time today, I'll briefly be discussing some of the features available in Adapt Builder for post-tension building design. I'll start out with a few slides giving a general overview of the capabilities and uses of Adapt Builder. Then we'll move into the program where I will show some of the features in greater detail. First, a few housekeeping items. Please be aware you can connect to the audio using your computer or even by calling in. Also, please use the Q&A chat box to ask any questions that you have. We have other engineers standing by to answer any questions that you might have. So what exactly is Adapt Builder? Adapt Builder is a three-dimensional finite element solution for building design in concrete, post-tension concrete, or a combination of the two. Adapt Builder allows you to model and analyze a complete 3D concrete buildings from foundation to roof, all within the same model. Specifically, you're able to analyze and design waffle slabs, beam and slab systems, podium slabs, as well as transfer slabs. Adapt Builder also gives you the ability to do a full structure analysis and design, including lateral loading, load takedown, column design, and wall design. This allows you to get a better idea of the as-built behavior and design requirements of your structure. Having multi-level functionality allows you to bring all loads and actions down to the base of your model to design the shallow foundation systems. These include mat foundations, pile-supported foundations, specifically pile caps, spread footings, as well as grade beams. Focusing in on the tendon modeling features, Adapt Builder can handle both bonded and unbonded systems with all the profile flexibility you could ask for. This includes single or two-end stressing, vertical profile adjustments such as CGS changes or when there are slab steps, as well as horizontal profile changes in the case where the column layout is irregular or when there are slab openings. There are also several tools for checking the general tendon layout, such as hairpin requirements when horizontal sweep is too extreme, and tendon uplift forces on a per span basis, which can help you determine where your vertical tendon profile might be too much. Adapt Builder integrates with other platforms, making it easy to incorporate your existing workflows. You can import geometry from AutoCAD and Revit to construct your model. With eTabs and Tekla, you can also import geometry, but you have the added benefit of loading and reaction import. Regardless of which route you choose, once your design is complete in Builder, you're able to export rebar and tendon information back to AutoCAD or Revit for drawing production. We're exceptionally proud to offer our round-trip workflow using Revit. This flowchart provides the general steps. In the top left, you would start with a Revit model and export the geometry to Builder. Then you perform the design to obtain the PT and rebar layout. Next, you import the tendons and rebar back into Revit, and then you'd be able to create your plan sheets. So let's go ahead and get into Builder, or into Revit. Here I have a model pulled up. If I rotate it a little bit, you can see we have some slab openings, multi-level structure, have a couple balconies with some slab offsets. So when you install our Revit link tool, you can find that under our Analyze tab. So if I go there and click Export, the first dialog window shows up asking if we want to use the default column parameters or if we want to specify custom parameters. In this case, we'll use the defaults. On the initial splash screen, this is going to walk us through the IMP file creation process, which we will then bring into Builder. This first export is more of a read-only. We'll get a little bit more flexibility on what is actually imported into our Builder model on the Builder side of things. So here you can see the levels that the export tool or link is detecting, and we have a couple of options here. The None feature will write all levels of the into the IMP file, even if a level is only a couple inches tall, which could be potentially problematic depending on the quality of your Revit model. The structural option will only import levels that are set as structural within Revit. And the active option, which is the one that I'd recommend using, imports only the levels that have structural components assigned to and are active. If we go over to our Components tab, you can kind of see a roll call of the components that the link is detecting. In this case, you can see we have 60 columns, 10 slabs, and 24 walls. Load cases, in this case, we don't have any in this Revit model. We do have some load combinations in here, but I'm going to go ahead and remove these from the export and build those out within Builder when we're in that program. So I'll go ahead and click Export Data, and then simply give this a file name. Let's call it Revit Export, and click Save. And in no time at all, we've taken our first step to creating our model in Builder. So we can set aside Revit and go ahead and open Builder now. If I click this drop-down arrow, I have a couple of options on how I want Builder to open. Since we're doing a multi-level structure and we want to do the slab design as well, we're going to have Edge and Floor Pro turned on in tandem. And since we're going to be doing some tendon modeling, we're going to make sure that the PTRC option is checked. This will give us access to the tendon features within the program. We're not going to worry about these features at this time, and we're going to go ahead and use our US unit system. So let's click OK. And upon Builder opening, we're presented with our ribbon-based UI, which is laid out in a logical fashion from left to right as you would progress through the model. So for example, you're going to set up your model criteria before you actually start modeling your geometry, and you're going to model your geometry before you add loading, and so on and so forth. In the middle of the screen, we have our model space, which is going to display our model's geometry, as well as give us our results when we actually get around to analyzing and designing our structure. At the bottom, we have our quick access toolbar, which has a lot of commonly used features, such as our snap tools, our different view settings, and the ability to toggle the display of certain elements within our model. So let's go ahead and import the IMP file that we just created. So if I go up to File, go to Import, I'm going to select IMP, and I'll navigate to the file I just created. It's right here. Click Open. And here we have a little bit more flexibility that we didn't have on the initial IMP creation. Here we can create a whole new model by selecting Create New Model. And if we wanted to just pull in a single level, we could do that. We could also update an existing model. Say if there were changes made to the Revit file, we could import those changes based on a specific level. In this case, we're going to import the whole thing. So I'll keep the Create New Model selected and make sure that I'm importing all levels. Our Load Cases tab is empty, as we saw on the initial export. And our load combinations are now empty because I removed them. Let's click OK. And just like that, we have brought in the geometry from Revit. If I look at an isometric view, you can see it a little bit better. Or we can even see a rendered view by clicking this little teapot icon down here. I can spin the model around. Notice we have all the slab openings picked up. And even over on this side, we have a balcony and some slab thickenings that are also being picked up. So as you can see, it's pretty quick and simple to create geometry using Revit. Now, you don't always have access to a Revit file. And when I worked in Adapt's consulting business for a while, my preferred method was actually importing via AutoCAD. So I'll go ahead and show you that real quickly. Let's actually set this aside if we want to come back to it. So I'll open up a new instance of Builder. If I go to File, Import, I have the option to select DWG. And I have a DWG over here for my typical levels. So if I click Open, I have a couple options regarding this DWG. I want to make sure that I calibrate it so that the scale of the drawing is correct when I bring it into Builder. If I had existing geometry in this model, I could select the Move Imported options to XY position. This would allow me to line it up with any existing geometry. This would be useful, again, if there were changes made to your model and you were importing updated version of CAD. You can also insert it at a certain Z position. So this is the different levels within Builder. Since this is a multi-level structure, I could put this in at any level that I wanted. I'll just leave it as the default. And then you can assign it the CAD as a certain group. I like to name it something different than the default, and typically I'll actually date it so that I know when this CAD file was imported. We'll click OK. At the top here, you can see that the program is prompting us to start our calibration. So I have a known dimension here of 10 feet. So if I turn on some of my snap tools, I can snap there, and then I'll enter that dimension, which is 10 feet. Click OK. Now it doesn't look like much has changed. If I go ahead and go over to our Home tab and use the measuring tool, I can actually verify that this is indeed 10 feet. So it looks like everything is calibrated correctly. So right now we just have our CAD line work in here, and notice when I click on one of these lines, it's a closed polygon, which is very useful in creating our geometry, and it'll make it very quick and easy. Same with our columns and walls. But not only are they closed polygon lines, if you open up the properties of one of these by double clicking and going over to the Properties tab, you'll see it actually imported our CAD layers as well. So if I go over into our Home tab and I select by a layer, I can select our slab regions. That one may not be very necessary since we only have a couple of slab regions. I could have simply held the Control key and clicked through them. Now if I go to Model, I can transform these into slabs. Let's go back and do the same thing with our columns, which that would be a little bit more tedious to go through and click individually. So this is going to make it much quicker. So if I select, and notice we actually even have some round columns and square, rectangular. Go back to Model. I can transform these into columns. And the program picked up which ones were square, round, all of that very easily. We have some openings as well. So we'll do the same thing. Back over to Model, transform into opening. Now we have some shear walls in the middle here. So one more time. Let's grab our walls. Now notice that these are compound or composite shaped walls. I could click the transform single wall, but that would just connect the endpoints. And since there's technically multiple endpoints, I want to use transform compound walls. The program snaps them appropriately and gets that taken care of. So right there we have created a single level of our structure. If I go to the rendered view, you can see that here. Now, we don't have any slab step or anything in that area, so we can go ahead and change that. But first, let me turn off the CAD so that's out of our way. So if I go over to our visibility tab and go to the group library, you'll see that the CAD group that I created on the initial import is here. And I can turn that off by checking this little light bulb. Now our CAD goes away. So if I go ahead and click this slab, I can actually change the parameters of it. In this case, let's say it's a thinner portion of slab and it has an offset. So maybe it's 6 inches with an offset of 3. Now I can verify what I have just done by clicking the section cut tool here under visibility. You can see that there. Now there is this transition zone in here which will be useful for pulling our tendons through that thin portion of slab that you see right there. So let's go ahead and increase this slab here so that we have a good transition zone. So since this is offset 3 inches and is 6 inches thick, we're going to set this one to 9 inches with the location offset of 0. If I click the green check mark and simply move this, you see it updates, and now we have a little bit more room to play with when we start adding our PT later on. Nesting the slabs in Builder is also pretty easy. We can simply just go into our modeling tab and add a slab. Perhaps we have a thickening over here. I'm just going to freehand it in. You'd probably want to start with some construction lines or pull in some CAD. But if I do that, and let's say maybe this is 12 inches thick. So it's almost like a drop cap. We can see that here. Again, going to visibility, doing a section cut right through Builder or through the area. And in Builder, it's pretty straightforward to get those thickenings, or if there's a thin part in the slab, it's the same process. So Builder can handle nesting of slabs very easily. I don't want this here for now, so I'll delete it. So one of the things that makes Builder very powerful is this idea of single level and multi-level mode within the program. So right now I'm in single level mode, and that's determined by this option up here. I can switch to multi-level mode by clicking here, but in this case we still have only modeled this one level. So let's go ahead and go into our level assignment, and here's where I can define the levels within the program or of our structure. So I could rename this if I wanted it to be level 1, level 2, whatever. You can also change the heights. But let's add a couple more levels. So I can simply click add. Let's do one more. I could rename those, but we'll leave it for now. So if I go into a side view here, you can see our current plane is the active level right now. It's also shown down here, but we're in single level. So if I switch to multi-level mode, you'll now be able to see all the different levels. And what I can do is select all of my components for this level, go over to the Modify tab, and I can copy this vertically. So in this case, we'll copy it 3 times, up, and click OK. And very quickly, we have a multi-level concrete structure that we can start doing design with. So I'm just going to pick one of these levels for the time being for us to work on. Now, I haven't gone into our criteria yet. I kind of skipped over that. We could go in there and specify our concrete materials, even add drum mixed steel fiber if we wanted to. I'm just going to use the defaults, but you can see you have your cylinder strengths, your modulus elasticities, all these other parameters. Same idea with your rebar. You can specify, yield strength, modulus, all of that. We can also specify our PT properties in here. And then further down on the ribbon, we have the different design codes that we could pick from. Notice some of these are disabled. Depending on the units that you select, will enable those or change which ones are active. You have a couple of different options to pick from, whether, what our tendon default heights are, our allowable stresses, preferred reinforcement sizes, shear design options, all sorts of things. And we can actually set these different parameters to unique situations. So we have beam criteria, one-way slab criteria, and two-way slab criteria. So if I make a change in our two-way slab, let's say beam actually, and we go over to our reinforcement, preferred reinforcement size, maybe we want to have number 10 bottoms. Now notice if I switch back to two-way slab, it goes back to number 8 bars. So these are unique to each one of these classifications, which becomes important when you start laying out your support lines. In this case, we don't have any beams in this model, so this isn't going to be that important. And we're going to be designing it as a two-way slab. So we'll click OK there. Let's go ahead and add some loading. So I can easily add loading by selecting either point, line load, or patch load, and then simply clicking and pointing. I can use my snap tools and snap to different components. In this case, I don't want any of these, but you can change the magnitudes and even have them as moments. You can change them into an X or Y direction. So you have some flexibility there. Let's delete those. We'll just do some basic smear loading on this portion of the slab. I'm going to leave the balcony alone since it's so thin. You could add different ones there, but by selecting the slab region, I'm able to use our patch load wizard. So instead of going through and snapping the patch load to each one of these vertices, I can just select the slab region, click our patch load wizard, and specify, in this case, a dead load. We'll use 15 PSF, click create, and we'll also add a live load. We'll do 40 PSF. If I go over to an isometric view, you can see the loading placed on this slab. Now I haven't talked about our default display button here. This is very useful. What you can do is you can go into your select set view items and you can toggle on and off different components and then save as a default. In my case, I like to have just the geometry saved as a default. So anytime I start adding stuff to the model, I simply click this and it'll revert back to my geometry. So now that we have loading, we could add some seismic loads in here if we wanted to do that as well. But we'll stay away from that at this time. But we have the ability to do that. With our loading in there, we could begin adding tendons if we wanted to and specify rebar. But in this case, I just want to check and make sure that everything is behaving as expected. Now, let me go back to our loading and make sure I actually added proper load combinations. I can go in here, and these are the defaults that are populated based on the code. You could add more in here, and then you can save them as a template to import them later or use for your future designs. In this case, I'm going to use the defaults. I could add a long-term combination as well. So if I click add long-term deflection, I can specify a creep factor here. I'll just use 2. And it builds out the long-term deflection load combination. So that's pretty easy as well. So let's go ahead and analyze. First, we need to mesh the structure. Sorry. So here we have our meshing tool. You have some options as far as mesh size, whether you want it to be sparse, uniform, and then also a distance to shift nodes. I'm going to go ahead and use the defaults. Since the geometry in this isn't too complicated, it shouldn't have a problem determining the appropriate mesh. So we're going to save this first. And we will now mesh, save and mesh. And there's our mesh, quickly created. I'm going to turn those off by selecting this. Let's go ahead and execute the analysis. I'm just going to analyze for, let's do a service combination so we can get some deflection. And then let's do a strength combination as well. And we can do a sort of preliminary punching shear check to make sure that we're not going to have some serious issues with some of these columns being too small. So we'll click OK. And notice, since I'm in single level mode, I'm only analyzing this one level. If I switched to multi-level mode and ran the analysis, the program would take into account the design of the entire structure. So ultimately, this is going to save you time by letting you analyze a single floor versus the entire structure when you start iterating on designs, which ends up happening with your PT. So the design is complete. And our results viewer populates over here on the right. So here you can see the different load combinations that we analyzed for. We have our service total and our strength dead and live. If I go over to analysis, I can expand the slab drop down and go to deformation and click Z translation. Get an idea of our deflection. Now these numbers are a little small. So if I go over to home, general settings, text settings, and change this, we can increase the font size a little bit, make it a little bit easier for you to see. So you can see we have a pretty big deflection over here of 1.25 inch. So this will be really nice when we start adding PT in this area to bring that deflection up, and same with this situation here. Now if I go into my rendered view, you can actually see a deformed shape here. And there you can see our exaggerated deflection, which obviously that's our worst case scenario. And we can even animate this deflection. So my mentor in consulting was always make the structure dance. That was the thing he always wanted. Make sure that your components are connected correctly. Looks like everything is behaving as expected. We don't have a column not supporting the slab or an area of the slab that looks like it's being supported by something that isn't there. So that looks good. Let's go ahead and close that. And we're going to clear our display. So I can click clear all button. And let's go ahead and go over to our floor design tab real quick, just to do some punching shear. So I could specify punching shear parameters. This is the same window that popped up when we were in the criteria. You have a couple of options to pick from, whether you want to use stirrups or studs, the size, the number of rails, and also some code requirements, such as limit rail spacing to 2 times the effective depth. So I'll turn that one on. You can apply minimum reinforcement for drift and consider critical sections outside shear reinforcement zones and other options. So we'll do that. Let's make sure so those are the same then. So we'll click OK. We'll go ahead and execute the punching shear check. That was done very quickly. If I go over here to our strength dead and live, since I only analyzed for this one strength combination, that's the only punching shear check that it did for this model. In this case, with the load combinations I have, this is going to be our worst case scenario. So that's why I did that. If I go over to analysis, we'll now see that there's a punching shear drop down. And the program's flagging as no good. So let's see. So if we open this up, the color coding is a little hard to see because the column's on top. I can just go to a side view, select those, and go to visibility and click hide selection. Make that a little bit more clear. So here we can see which ones are exceeding from code and which ones the program is saying we need to reinforce. We can check our stress ratios as well as the condition that the program is treating them, whether they're an interior column, an end edge, or a corner. You can see up here in the left kind of the legend is how it's being treated. So it looks like some of these are exceeding code, and we may want to increase those. For now, we're not gonna go through that process, but that could be something that before you start getting too in depth into your design, this is something you probably want to look at. And that's just a check I like to do. So let's go ahead and now start adding support lines so that we can design this floor system. So the support lines are creating tributary regions and then taking section cuts for the results of the FEM analysis. A new tool that I like using is the dynamic editor. This wasn't available when I was in consulting, and it is a huge time saver. You used to have to snap to the slab edge and then click individually on each column. Now you simply just draw this line through your columns and click wherever, and the program will pick up. Now if I pause this, it will pick up the supports, and you'll see it adds the control points over each support appropriately. So let's go ahead and add a few more. We'll add a support line here. Now for walls, you have to click twice because you want a control point on each end. And then I'm pressing C on my keyboard to end the command. I'll do this one as well. And here. One more here. So that's the X direction. We'd want to do this for Y direction as well. We'll do a couple since we're going to be doing a banded direction of cables and distributed direction of cables. Looks like I'm going to miss that column. Let's try that. There we go. In this case, I could, I meant to move that one over there. In this case, I could split the support line in a Y shape here. I'm just going to have it terminate here, a little past the column. So support line layout is the way that you're expecting the slab actions to work and where stresses are wanting to be checked. So I'm kind of laying these out in almost like a load movement fashion. So I'm going to stop there. I could keep going. Let's go ahead and update this support line real quick. I can turn on some snap tools. And if I right click here, I can insert a vertex very easily. And just like that, that problem is solved. Now I drew that support line outside the slab. You can come through and clean that up. In this case, I'm all right. I'm okay with doing that. Now we're going to generate our sections. Now you can see, if I only turn on our X direction, looks okay. You can see that it picks up the tributary widths based on adjacent support lines. In this case, we have support line kind of crossing over this opening. We may not want that and add another support line in there, but you can go through and refine these results as you see fit. Now in the Y direction, since I didn't add all of my support lines, this support line is trying to figure out where its tributary is. And in this case, since I didn't complete them, it's going all the way to the slab edge. And obviously I don't want that. So what I can do is I can add what's called a splitter. And I can just draw this here and say that's roughly what the tributary should end for that support line. Now if I generate the sections again, you see it cuts it up to that support line or that splitter and stops there. So let's go ahead and start adding some PT. In this case, I'm going to assume that the banded direction is in the X direction. So we will keep our support lines turned on. And what I can do is clean up the display a little bit. So I can select a support line here, go over to our tendons tab, and I can map a banded tendon to the support line. So when I click this tool, the program is going to ask me what the rough tributary width of this area is. I'm just going to use 20, and I think the spans are about 30 feet, they're between 25 and 30 feet. So I'll just leave it at 20. We can specify the average pre-compression for the minimum and maximum, and then also a target self-weight to balance. Now, I like to raise this a little bit, though there isn't a full code requirement for this, by me increasing. What this is actually doing is the program is going to input tendons for us for a good starting point based on the geometry and the tributary width, and then these parameters. And if I increase this, this is going to allow the program to increase the drape of our tendon a little bit more. So getting us a little bit more uplift in maybe some of the spans that are larger, even though the self-weight might be a little bit, the self-weight may not be controlling it, may be the deflection. So I'm going to increase that. And then I can specify how I want this placed. I can idealize it as 2 groups with an offset, or I can do it as 1 group. In this case, since I have this opening here, I'm just going to do 1 group. And in fact, I'm going to have it go up about ½ a foot. I can specify the effective force. And then I can also specify the shape of our tendons for along the support line. Now the first span is the one on the left. And in this case, we're going to want a cantilever down shape. So I can select that here. The mid span is going to be all the spans in between. And then the last span is going to be the span at the far end. And over at that end, we just had a column similar to this condition where it's right against the slab edge. So we'll click OK. Now, if I double click this, we can see that the program is specified you're going to need roughly 10 tendons for this area. We can change our stressing in here. We're going to go ahead and use effective force, but if you wanted, you could use calculate force and include all of your losses. The shape and friction tab will let you see the profile. Now, there is that balcony that we have over here, so we have a little bit of an issue with the tendon coming out of the slab, so I can easily change that here. Let's drop this down to, let's do 4 inches, just to make sure we have clearance. There you can see it's not going through the slab now. And the drapes aren't really being adjusted for, but notice that it did pick up that we have a wall in span 4 and change the profile to straight. Now over here we have a little bit of a problem, so we can go over there and fix that real quick. You can see it added this tiny little span. So if I right click, I can delete a vertice, just select it. If I select this tendon again, I can click trim extend, and that'll move the tendon to the slab edge. So that's pretty easy. I could also just freehand a tendon in here if I wanted to. So let's go ahead and just add a tendon in this area very quickly. I'm just going to have it go along the support line. Let me turn off that snap tool. Now, if I click this tendon, let's just say we have no idea what amount of PT we want in this. So we'll just set it to 1 for now. We can, now that we've added PT, we'll have to do the design to check. So let's say I'm doing some preliminary work on this tendon. So I'm going to go into analysis, execute the analysis. We're just going to do our surface total load real quick and get the results for this slab, taking into account the PT that we've just added. So obviously, if I go over, turn on our service total load, we need to design the sections first. And now the design sections drop down is available. And if I check, I can go into our stresses and see where our stresses are too high, too low, what our pre-compression is, and I can turn this on. And anything that is not good is flagged in pink. Obviously, our pre-compression is going to be a little low, especially over this area, because I only have one tendon. And I'm showing this because we have another great useful tool for determining PT amounts. So if I go back into Tendon, we have our tendon optimizer. So I can click this and select a span. In this case, we'll say this is a 20-foot span. Click OK. And the program is now checking inside this square area. Notice there's a section cut A, section cut B, and section cut C. And over on this window, this red line is our current status. And this is the estimated value that we need to be at to satisfy code requirements, pre-compression, stresses, and whatnot. So what I can do is I can click Edit. And here you can see, okay, after we make these changes, our pre-compression is going to be 129 PSI, which would be adequate. The load balancing would just be under 100%. Our current stress ratios, and then our estimated stress ratios after these changes. So I'm going to go ahead and apply additional tendons. And notice we have one tendon there, and it's saying you're going to need about another 9.3, which is similar to the 10 tendons that we have up here. So maybe we'll increase this one to 11 because I was seeing a couple of stress issues over here. Now that I've changed that to 11, I can click Apply to Model. And here I can either distribute these added tendons to the one tendon I've had added already in there. I could create a new tendon over here or specify which tendon we want to modify. In this case, we only have that one. So I'm just going to apply it here. You have the option to rerun the model. We won't do that, but I can click Apply. So these are the old results. Now, if I went through and reanalyzed, we would expect that this would be much closer to a design that would get us off on the right foot, similar to what was up here with these tendons. So we've added some banded tendons. I could go through and add banded tendons here, and let's go ahead and do that because we have an interesting situation here with this column. So if I go ahead and add a tendon, let's actually map to this one as well. So if I go into floor design and turn on my support lines, I can map another tendon to this by going to tendon, map banded. This time we will just do one, but we want this one. We'll do half a foot down. We want the cantilever profile over on this end still. We'll click OK. Notice the program is saying, hey, you have a problem. This tendon is outside of the slab, which I knew was going to happen. So we'll fix that. We also have that same issue that we had earlier with that additional span. We'll just delete that vertex real quick. Select the tendon, trim, extend. And this is outside of the tolerance. So what I can actually do instead is I could drag it and move it. This brings up another useful tool that we can use, which is our tendon editor. And here this lets you make mass changes to tendons without having to individually click on them or open up their properties window individually, such as this, and modifying them. What I can do is, let's turn on our CGS real quick, which would be under here, control points. For some reason, they're not being shown. So what I can do is in here, if I go to the trim option, I can increase this tolerance, say to 3. And now if I window this, it'll change that. And I could do the same thing with CGS. So this gets really useful when we start adding our distributed tendons. Say if all of a sudden we have way too much uplift in this bay and we want to raise all of those tendons CGS from the bottom of the slab, we can change that and window select them all, and it'll change them all in one go. You can also change the number of strands. Here, in this case, we have 10, which is probably too much. So let's decrease this to 5. So if I just select this tendon, now it's 5. We can change the mode. And in this case, we're going to want that. So these tendons, as you can see, I've specified as straight lines. Those are just going from each control point that I've clicked. This isn't necessarily how they're laid out in the field. You know, you have some nice sweeping motions to them. And that's where you can specify these different mode shapes. So in this case, I'm going to use fillet on this tendon and just select it. Now it doesn't look like much has changed because this tendon was relatively straight. But if I go over here, I can now insert a swerve point on this tendon. And what this swerve point is going to allow me to do is actually swerve this tendon outside of the slab. Now, since I have that control point is going to move. So maybe I move this control point there. And you can see I can adjust that and move that around as much as I want. I could add additional swerve points. I have a ton of flexibility with that. And what's really cool is the tendon profile is still the same. Looks like there's a little bit of a graphical bug there. The tendon profile is still exactly the same vertically, even though I've added this horizontal sweep. And this will be helpful for in this situation where we have some openings down here and those types of situations. So let's go ahead and add a distributed tendon. So what I would do in this case is I would just draw in a tendon manually. Let's turn on some of our snap tools. And we'll go here. And turn on snap perpendicular. What I would do is I would adjust this as kind of our master tendon, so to speak. So in this case, I'm going to put 2 strands. Let's change the profile shape. This is a little extreme. You can see we actually have our estimated uplift kips per foot reported down here, which is very useful in kind of determining a good amount of drape in your tendon. So these last bays are a little extreme, so maybe we raise those up to 4 inches. And you can see that gets those a little bit closer towards kind of this interior span where we're going to have all of that deflection as we saw earlier. So we'll accept that. And now I can select that tendon, go over to modify, and I can copy this tendon over. And in this case, with an 8-inch slab and 2 strands, it's good to, in this case, for pre-compression reasons, about 4 feet. So I'm going to copy these 4 feet, and we'll do it, say, 7 times, and copy. Now, we'd want to adjust all of these CGSs so that they're going over this banded tendon. So a little bit of cleanup here, but pretty quick and easy. I won't go through all of them, but you get the idea there. And let's copy this one over one more time so we can see a difference in our results. So we'll go back to modify. In this case, we want to go in the negative X direction, and we'll copy it. We'll just do 1 tendon this time. So copy. Notice the program picked up the slab edge in this case. Okay, that looks good. Now, obviously, I'd go through and add all the other tendons throughout my model. We have these tendons going through openings, so we're going to need to actually move these, or the program is going to warn us that this is the case. So let's change this here real quick. since we are getting close on time, I'm going to insert a swerve point there, maybe this one as well. Insert swerve point. And one more here. That one is not the right tendon. There we go. And insert swerve point. So here, if I just click there, move that out, that's clearing that opening. That's clearing that opening. And if I wanted, I could split this tendon since I have two different tendons here, or two strands simulated by this one. I could actually copy this one over, maybe change this to one strand and have another strand going on this side of the opening. You can get as detailed as you want with this. Obviously, I don't want to spend a ton of time in doing the PT, so you can get a rough generalization of your design. So let's go ahead. Oh, sorry, my computer's running a little slow. We'll save. We're going to reanalyze. We'll just do the service total again. Since I've changed tendons in the slab, I need to get a new FEM solution. So we'll wait for this to execute. Here we go. Let's see what our deflection is now. So I'll go ahead and turn the tendons off. We don't need to see those. We actually might have a problem with this tendon now that I think about it. Yeah, the drape's a little weird there. Obviously, we wouldn't want that. Probably get some moment being cranked into this area, but it's okay for now. Let's turn tendons off. I'm also going to I'll leave the support lines on. Let's check our deflection. Remember, we were at 1.25 inches of deflection, and now you can see our deflection has gone down quite a bit, actually. This is no longer our problem area. It's actually over here, and we don't have any significant amount of PT in this area yet. We do have that one tendon going from there to there, but once we would add our distributed tendons in the Y direction, obviously that would aid in that deflection. So looks like the tendons are working in there. Let's go ahead and design the design sections and see what our stresses are looking like. I have a feeling we still have some stress issues. We haven't spent that much time refining. Yep. So here we go, display our design sections. See, all these are looking pretty good. We have a couple here right at the face of these walls just because of the span. We could add some tendons here that went from here and then anchored into this wall to help lift this area without raising, the pre-compression over here, because these spans look pretty short. In fact, we're not really getting any bottom stresses. In fact, it might be the opposite, where the bottom is actually in compression at the midspan. So a little too much PT uplift in this area potentially, so we could adjust the profile there. And again, like I said, add tendons in that area as well. So let's say our design is adequate at this point. What we could do is we have our PT. We can generate a rebar drawing now that we've designed the sections very quickly just by calculating a rebar plan. And this will envelope all of our different load combinations. In this case, we only have the one. So we'll go ahead and click OK. And you have some flexibility on how the rebar is laid out. In this case, I had it just mapped along the support line, so that's why we're getting this these acute and obtuse angles. I could also redo the rebar plan and change it to 0 and 90 degrees in this case. That'll straighten them out probably more along the lines of what you would expect to see. And notice that we have a significantly larger amount of rebar over on this side because we don't have our PT, obviously. And at this point, we could actually take this rebar and export it into CAD by going to File, Export, DWG. And that would create a DWG for us. The other option we can do is we can export this to Revit. So and that would include tendons. So we need to first make sure that the model is set up to export tendon segments here. And this is automatically turned off because depending on your model size and exporting this to Revit, it can take some time. So we'll go ahead and attempt this export into Revit. But before that, you could go over to our report section and you could generate reports here, either individual reports as seen here, such as different structural reports for your columns, slabs, walls. Same with loading reports, so you can see how the slabs are loaded, any skip patterns that you have applied. Tendon reports, rebar, punching shear, which I very briefly touched on. We could do another punching shear check. I didn't actually analyze for a strength combination, so we'd have to go through the analysis again, but I think we will be running short on time for that. And some column reports and whatnot. Or you can open up the report compiler, which will put it all into a nice organized report for you, depending on the different sections you want to include. So if you want to cover, or you want to include a tabular report for tendons, there's a punching shear report in here. You can also take screenshots using this tool up here, and those will be populated within this report manager, and you can add those over. So you can see if I just kind of select some of these, this is what's going to be in our report. And you can order it as you see fit. So let's go ahead and export this, see if we can get it in time. So I'm going to export as IMP, all levels. There's our Revit export that we brought into Builder earlier. Let's call this one Tendon Export. This one's now from Builder, obviously. Click Save. Now if I go back into Revit, let's open, we'll go Analyze, Import. We're going to use the default parameters again. Tendon Export. Click Open. Here, notice that it is picking up the slab reinforcement as well as the post-tensioning that we had designed for that single level. So let's click Import Data. And this may take a few minutes, as it says right there. So if this gets done in time, I can kind of show what this would look like. Looks like it's going pretty quick since I don't have a ton of data in this model. It comes up with a report of any warnings and errors. We'll just click OK for the warnings. I don't want to see the log. And you can see already, if I go down into, I don't think I have a view for that level, unfortunately. But you can see down on this level 1, some rebar that is being brought in. And if you click it, you can see the rebar properties were brought in from Adapt, and even the tendons, which are over on this side. So if I click this, you can see this is tendon number 7, and it even tells you the total force. So in this case, 53.4 kips was the 2 strands that we added in the banded direction. So this could save you a bunch of time on creating your drawings and for your submittals. So we have now run out of time. I appreciate everyone's attention during this very brief overview of Adapt Builder. We could have spent several more hours talking about all of the features. But I hope you all have learned how this program can save you a bunch of time and effort in your concrete and post-tension concrete designs. If you're wanting to learn more about Adapt Builder or more about the other Adapt products, I invite you to check out our YouTube page or email us at adaptsales@risa.com. We'll be more than happy to provide you additional information and answer your questions that you have. So this webinar is PDH qualified. You will be getting the certificate via email within a couple of days, so be on the lookout for that. Thank you all for joining us, and we hope to see you next time.